Hello, my dear students. Uh, just what we have decided, and as per that, what the uh, last episode, or you can say last part of the circle, we have studied some theorems about congruent chords of a circle. In this series only, actually, I wanted to attach that this today's session with that, but that might somehow that episode or that part might have become a longer. Therefore, I just would split it this into two parts. So today, just what I want to discuss about, you see theorems on congruent chords, and that theorem, you see that the theorem statement of the theorem is if you see that if they'll say that if the chords, two chords of a circle are congruent, then that chords are equidistant from the center. You see, boys, for the sake of saving our time, that what I have drawn this diagram for you. So here in this, O is the center of the circle, and AB and CD are two chords of a circle. And you see that you know that any distance that we measure, suppose for example, you see if you see this is the point A, and if this is the point B, then how you measure the distance between A and B? So obviously, you see, we will not go forward here, or like this. So this is not actual distance, shortest distance between 2 points. So for that, you see that what you need to draw a perpendicular on this one, B to the B, and then AB we can measure. So what, in short, we can say, if we want to measure the distance of these chords from the center, then we'll have to draw perpendicular. So in this, you see OM is the perpendicular on AB, and CD is the perpendicular on a ON is perpendicular on CD. So in this case, we see that this is a statement of the theorem. So this theorem also can be asked for 3 or 4 marks in your examination. So that is why it is very, very simple but very important. So you say again, you say this is the rule of the theorem is that what key will have to write the given. So given, you say whatever what we draw in the diagram is nothing but a given. So O is the center of the circle, and you can say that AB and CD are the two chords, and they are congruent. So you can say in the statement also, or you can show the sign of congruence over there. And you see, we'll have to prove that. To prove what? To prove here the perpendicular distance, that means OM congruent to OM congruent to OM. So we'll have to show this one. For this construction, we need to draw. Construction, again, you see that draw perpendicular OM, and OM perpendicular to AB, and ON perpendicular to CD. And see that AB and CD are two congruent chords. So in this what we can say that we have to prove that, or we have to use the earlier property of perpendicularity of this the line drawn from the center, or perpendicular drawn from the center bisect the chord. So this theorem what we have to use. So in proof, what we say, in triangle, there are two triangles, triangle OMA and triangle these are two triangles, and obviously as we draw a perpendicular, therefore it is that a right angle triangle. Therefore they are what? Right angle triangles. So in RAT, what we in short what we say, right angle triangle. Okay. So here again we'll have to prove these two triangles congruent. Then how? That I will show you. First part though very simple. It is segment OA is congruent to segment OC. Reason for this one is radii of a same circle. That what we have just shown that earlier. OA equal to OC. Now let's see that this is angle ONC and angle OMA are right angle triangle. No need to write, but just you say for clarification, or you say to represent your theorem very systematically, you need to write that again. Angle OMA equal to 90 degree, and you say that this is second equation. Reason is construction. Reason is a construction. So this becomes a two right angle triangle hypotenuse. That what we segment OA and OC what we have proved. Only one side is to just what to show it is a congruent. But you see that what there is no this is third side of this triangle ONCCN, and here AM. We'll have to prove this. We'll have to prove this. These are congruent. How we can say that AB? See, AB congruent to CD. It is a given. It is a given. So you know that by Euclid's postulate, the same. If you just divide two equals, the resulting you say quotient is also equal. So I just what multiply or divide, you say by 2. That means half of AB. We can say half of CD. Half of AB equal to half of CD. So if whole are equal, then half of that also equal. This is Euclid's postulate. So you need to mention. You need not to mention, but if you mention it, then also it is okay. So half of AB equal to half of CD. So we know that half of AB is nothing but a AM, and half of CD is nothing but a CN. So this is third equation, and you say from 1, 2 and 3. From 1, 2 and 3. Equation 1, 2 and 3. We can say that these two triangles, triangle OMA congruent to triangle ONC by RHS test, or you can say hypotenuse side test. So if these two triangles are congruent, then we can directly say that this OM is congruent to ON, and this is nothing but a perpendicular distance. So see that this is very simple. We can say CPCT or CSCT in a straight board. This is what very important. So this is the theorem that what I wanted to discuss you. So this is also very important theorem. So if you want to take the screenshot, you can take the screenshot so as to just see the detailed step. Then we'll proceed further for its converse. Now, boys, you see the same theorem statement. If the statement is reversed, then we can show that what key. If statement is reversed, then what will happen? This is nothing but the converse. So if you see, if two chords, what is the converse statement? If two chords are equidistant from the center, then we need to prove that chords are congruent. See, exactly a reverse statement is made in you say converse. So again over here we can use this same figure. Only we can say that this yes, we need no need to mention this rub this one here. just to remind that earlier theorem, they have given OM, they have given somehow what AB congruent to CD, what we have given. In this theorem, we have to prove, we need to prove AB congruent to CD. They have not given. But here in this theorem, they are given these two chords are equidistant, means they are just what placed or drawn exactly at the same distance from the center. So in this case, they said in the given we can say that whatever the remaining part, what it is, you need to write it only. But here the special thing is that OM congruent to OM congruent to ON, it is given. It is a given over here. Okay. Now you see, and these are the perpendicular. These are perpendicular. And again, what to prove that? To prove is nothing but to prove. What to prove? Here, AB congruent to CD. AB congruent to CD. AB congruent to CD. So this is very simple. You can say this is very simple theorem. What we have to prove that. Here, what to do now? Again, you say for in a proof we can say in a proof what to do. In a right angle triangle, which right angle triangles are there? Again, same OMA triangle OMA and triangle ONC. In triangle OMA and ONC. Just I check my change my that. It's okay. OMA and ONC. What it is given? First you will write AB congruent to CD. AB congruent to CD. It is given. Then again we know that OM perpendicular to ON. That means you say angle OMA congruent to angle ONC. Angle ONC. It is equal to 90 degree. It is given. Okay. Then here in this step over here we need to just what it is AB congruent to CD. It is not a given, but it is to be proved. It is to be proven, or it is to be proved. Here we can say the segment OA congruent to segment OA congruent to OC. Why? Because radii of a same circle. Radii of a same circle. So these two, you say parameters of the triangle, it is a given. Two parameters of a triangle, it is a given, and we'll have to show that you say this what AB congruent to CD. Now you see that what by two, you say this is the this was the hypotenuse and this is the side. So by RHS test, we can say we can say these two triangles, triangle OMA congruent to triangle ONC are congruent. We just what we wrote over here, but we can say this is an RHS test. So so for what you see that what we have just shown over here, these two triangles are congruent, but yet our work hasn't been finished. So here by CPCT we can show that what you say the third side AM congruent to CN. We can say by CPCT or CSCT. Once you know that what we say, key two triangles if we show somehow congruent, then we can show other three parameters also. But you see that AN is equal congruent to CN, but we'll have to show that AB congruent to CD. So we just multiply this equation by 2 on the both the side. Again, that Euclid postulate. So twice of AM congruent to twice of CN. Twice of AM are equal to twice of CN. And you know that by perpendicular, theorem of perpendicularity, theorem of a perpendicular to the chord, you know, bisect the chord. That means you say AM twice of AM is nothing but AB, and twice of a CN is nothing but a CD. So in this way, you see that this theorem can be proved in short and very, you say, stepwise method. So what I observed during of my last experience, the students know how to just what go through, but just what they avoid some mathematical steps. And you see in the examination, you see if you wrote in your word, it just what does have a very low value of the marks. So you need to just what take the just what I did over here. I just multiplied it by 2. This is Euclid's postulate. So you can do multiply, add, or something on both the sides of equation. Then the value of equation doesn't change. That is what are the mathematical steps. So you need to just prove your statement by using the mathematical steps. So if you want to take the screenshot, you can. Then we'll proceed further. One more very important and very interesting concept of a circle. So boys, till that what we have just seen through theorems, and just what I want to add that one very simple or another concept that is nothing but an arc of circle. Arc of a circle. So you see arc is nothing but one part of a circle. So you say circle. If I draw this one, and you see if I draw same, but if I consider somehow this all means I just make shade or just use this all. So you see these two figures, you look like same, but I'm just considering the outer part. This is circumference of this circle. And here I just consider circumference along with the area enclosed over here. So in simple or very local language, what we can say, this is nothing but the bangle, where internal area has not been considered, and this is nothing but our bhakari or chapati. So what we say that the internal part is very important for us. So if somebody gives you chapati like a bangle, then we will remain hungry forever, right? So this is the way of this. This is nothing but a circle and or arc of a circle, circumference of a circle. Now, if I cut this by using secant or chord, you draw the segment, then what will happen? You see, this is a bigger part. We'll just cut over here, and this is a smaller part. This will cut over here. So this is nothing but this is a smaller, therefore it is called minor arc, and this is called major arc. Minor and major. So this is very important concept. So if you just break the bangle, exactly same. Nowadays what happens? This is a very a rare thing that what we see, that if you are well, then you know that the use of this one now it becomes rare. But for the sake of with the help of my ex-students, means 8 to 10 years back, we just made the model that I will show you afterwards if time just allow me to show that. But this is the concept of major and minor. I think so. You have just got clear what is mean by the arc. So there are 2-3 theorems regarding with this arc. So again, you see, if I draw, this is a circle, and now you see, if I draw this AB is a chord, and this chord makes somehow some part of the circle, minor and major. So generally, you see, the arc is measured, or arc is just labeled with 2 letters AB. Arc, you can say arc AB, or generally you say avoid the confusion. We can say take another, or say point X on this arc. So arc AXB, we can say like this, or some may say in a bracket. So this arc. So you say how to measure this arc. So we don't have that curved. You say what? curved scale to measure the length of arc, and there are some different or more formulas over the length of arc, measure of arc, and everything. So that will be studied, you see, in the next our videos. But here we can say how to measure. So this measure is measured in somehow not in centimeters, but it is in degrees. And this degrees is nothing but, you say, if this is the center, and you see, if we join this, if we label it as the center O, then we know that key is a measure of arc. If we want to measure the arc AXB, that is nothing but we need to measure the measure of angle AOB. That means the two ends or the chord which makes an angle with the center. This is nothing but the central angle also. Central angle. So the measure of arc is measured in the angle right now. And again, one more, just what need to say, as this figure is somehow very suit for this concept, and you know that key. If I join and just we say and if I take this, we can say Y. So this chord is responsible, or just what make, as the angle AOB, the angle with the center, and angle AYB, this angle is somehow made by the same chord AB or the same arc. Therefore, this angle is called an inscribed angle. Look, this is an inscribed angle. And you see, there is some relation in between. This is inscribed angle, and this inscribed by this arc AXB, and which is just what subtended in the major arc. So angle made by the minor arc is just subtended in major arc, and angle made by major arc is subtended in a minor arc. That I will show you later. So that just to avoid your confusion, I just what going step by step by step. So this is one inscribed angle, and again, just what showing you. We will prove this theorem. Again, this is the theorem for very important theorem for 9th standard CBSE and also 10th standard. So we'll discuss that one later. But this is the inscribed angle. So this inscribed angle and relation between this inscribed angle and the arc. What it is? So this theorem says that this measure of angle AYB. Measure of angle AYB is nothing but is equal to half of measure of arc AXB. So this is the theorem, and this is that many times the theorem has been asked for 4 or 5 marks in the previous examination. That we'll see in detail. So this is the concept of arc. And again, I just want to say that how many angles we can make. So we can make you say number of angles just made by this means we can draw many angles, you say. So obviously you say there is one more theorem also. This all angles are of same measure. That means they are congruous. So that we'll discuss afterwards. So I hope that key used to 2 theorems related with chords and concept of arc that you might have got cleared. Thank you very much for watching this video. We'll see or we'll meet in the next video.